Welcome back to the next video, everybody. Today we're going to push further into chapter 8 by looking at deformations, group representations, and what it means to study a deformation problem. So let pi be a profinite group. So we have a coefficient homomorphism H from A1 to A0. Remember, a coefficient ring homomorphism is just a ring homomorphism that induces an isomorphism on residue fields. Let n be a natural number and denote also by H the induced homomorphism from GLN of A1 to GLN of A0. If rho 0 from pi to GLN of A0 is a continuous homomorphism, then a deformation of rho 0 to the coefficient ring A1 is a strict equivalence class of liftings, rho 1, from pi to GLN of A1, such that the obvious triangle commutes. So you're literally taking rho 0 and physically lifting it up to A1 from A0. Okay, and we say two lifts, rho 1 and rho prime 1, are strictly equivalent if one is the conjugate of the other by an element of GLN of A1 and the kernel of H. So you're allowed to kind of conjugate up here with a fixed element here without changing the equivalence class. But whatever matrix you conjugate by up here better not be detectable down here on the level of rho 0. All right. Note finally that any representation rho is definitely a deformation of its underlying residual representation rho bar from previous videos. All right. I'm abusing language a little bit there. Of course, what I mean is any equivalence class rho bar is a deformation of its underlying residual representation or the underlying residual representation of one of the elements of the class rho bar. Okay. So let A be a coefficient ring, and let's let C hat of A be the category whose objects are coefficient rings A1 together with a coefficient ring homomorphism from A1 to A. Such a map is called an A augmentation. What are the morphisms in this category? They're commutative squares of coefficient ring homomorphisms. So look, you have two elements, A1 to A0, and A1 to A, excuse me, and A2 to A in C hat of A. So what should a map between them be? Well, it should definitely be a map from A1 to A2 because these are sort of the objects of focus in the category if you just kind of ditch the maps to A. And then what should happen with those the map from A1 to A2, it should just commute a square, right? Okay. So by hypothesis, more precisely, the definition of a coefficient ring homomorphism, all objects A1 and C hat of A have residue field K, the residue field of A. So everything in this category has the same residue field K. All right. So what's a deformation problem for a representation of a profinite group? If pi is a profinite group and we have a continuous homomorphism rho from pi to GLN of A, define the functor d sub rho from C hat of A to sets by the rule that assigns to any object A1 to A and C hat of A the set of strict equivalence classes of deformations of rho to A1. And then by a deformation problem for rho, we just mean the study of the functor d sub rho. Okay. So next time we'll look a little bit at the notion of why we should study Galois representations relative to the theory that we've developed over the last couple of videos. So I'll see you then, and thanks for watching.